Hey guys, welcome back. Been a while, so sorry, apologies about that. I've been waiting on quite a few different bits and pieces to arrive. So you can see just sitting over the back, the motor controller's arrived. That's a Servcon. So we can use that for road going use, and it's completely legal here in Australia because the Zero motorbikes use that one. Got my charger over the back there, I've shown you that already. I actually custom made a chill plate for the Servcon controller to sit on top of, so that'll connect to my water cooled loop. And you can see up on the top of the battery box, here's the other chill plate. So this works to remove heat from the top of the battery. Quite a bit of work done here. You can see I've got most of the cables through. Thankfully I ordered really high quality cable, so it's very flexible. So you see down in here there's hardly any space to work in, so I'm working in really tight area for the cables to sit in. Just got these ones ready for termination up onto the bottom of the main disconnect fuse. It's a bit hard to see also, but you can see over the back there's the heat pipes, so they're sitting there ready to start pulling heat up out of the battery, and over here into this section of the chill plate, we can see that there's your main water lines to take the heat away, and also I've got my DC-DC converter, 300 watt, sitting straight on the top of that chill plate as well, so doesn't need a giant heat exchanger on the top. Eventually I'll place a few more parts up here, like AC to DC converter for when we plug it into charging stations, and probably the little main control unit that I'm using to control the motorbike. I think it's a Motoride, yeah, Motor Gadget, so this little guy. I'll stick up on the top there as well, out of the way. So I'm trying to be as compact as I possibly can. So we've got our two main contactors for positive and negative on the battery, and we've got our main contactor for our motor as well. I was lucky enough to find these two contactors secondhand, barely any use. They've been pulled out of the battery box or something like that, and this one I was able to get online because contactors are really hard to get at the moment because of the solid state stuff. And you can see here I've had to make a custom bus bar to bring up one side of the positive from the battery pack. It looks a bit messy, but this is a Nomex tape I've stuck over the top, so I can't rub it on anything or accidentally nick it with a tool or something like that where I knock it on there. And you can see on the other side over in here there's also a custom bus bar I've made as well that sort of slots in neatly there, so it's a bit hard to see with this top on. And then we've got our negative coming up from the bottom. I haven't connected that yet, so you can see that there's just enough space to fit that in there, and that comes up and around and tucks in behind that bus bar there, and then goes up through here. You can probably see the white bits of tape. Again, that's Nomex tape. It's really abrasion resistance, so just to stop anything from potentially rubbing on up in here on the edge of this chill plate, or the cable rubbing on the back of this bus bar. I mean, it's probably overkill because these conductors are double insulated anyway, and this external layer is called an X-Rad product, so it's a cross-linked process where they irradiate this polymer, and it's so hard to cut. I mean, you can see I was using a really sharp Stanley knife, and it's really hard to cut and to get to tear. So probably overkill, but can't be too safe because that's negative there, that's positive right there. They run past one another, So they're fully wrapped in Nomex, 2 layers of insulation underneath that, plus capped on tape as well. So really they can't move around that much because these will be glued in here as well with some 2-pack adhesive, and it's the same on this side as well, so same here. So these are bolted through here, and then obviously Loctite and spring washers, and these will be the same as well. So I've glued this one on the back, and this will be Loctited through here as well, on the back of this bus bar. So yeah, so the I guess the reason I've done that is that this can do 400 amps continuous at 120 volts, and there'll be no fuses in here, so it will probably destroy the battery pack if they short it out. Probably almost certainly catch fire as well. I've created these 3D printed blocks up in here as well to space and hold down the top of the battery pack, and then once I put this top on, I'll put the side plate on, and then we'll compress it slightly, and all of this will get compressed down. It won't be a huge amount of compression, but enough. And then I'm also compressing with this fiberglass tape as well. So it turns out fiberglass tape is really good at insulator, but also really good at holding tension and compressing that battery pack to stop the batteries from swelling and shrinking and swelling and shrinking and rubbing on one another all the time. So it's really good for NMC cells to have a little bit of compression on them, not much, and that helps prolong the life of the battery because it stops the chemistry from breaking down the layers in the cell, and also makes it a hell of a lot safer. You can see around the back here I've got these little spaces I've 3D printed out as well. They sit between the end of the cell holder, so this is your cell holder here, so they sit here. So they sit on the end of the cell holder, and then behind the PCBs that, and then obviously between that you've got the bus bar clamping as well. So what that does is that if there's an impact on the back of the battery pack or on the front, the load's transferred through the bus bars, through the fiberglass PCB, through this spacer and into the end of the cell holder, rather than into the tab on the cell, and then potentially bending that tab or punching that tab into the soft plastic in the cell. So this should put up with a fairly large impact. So should I crash the bike or someone hit it with a car without shorting or impacting on the cell itself. And that's there's a lot of people building electric bikes online at the moment, but a lot of them don't think about protecting the cell in the event of a really big accident. So yeah, I'm going to keep wiring up in here. It's a real pain in the neck, and I won't put you through the torture of me just terminating big fat cables off. I've got 2 cables rather than 1 because the little cables will bend. Because you can see I've got some pretty extreme bend angles in there going up and around into the bottom of this main disconnect. So and it's actually pretty damn impressive how well this bends without actually causing the cable to fail. I think the Chaplin cables really undersold how flexible their cables are. They're absolutely incredible how well they'll bend. And you can see there's a complete 180, and that's a 16mm cross-section cable, and it hasn't strained or stressed or snapped any of the internal copper cables inside. Just the design of these cables is really, really nice, the way they've set out the cable inside the sheath, and it really does matter. There's a lot of A lot of design, a lot of technology goes into good cable, and everyone's like, oh, it's just a cable. Well, no, it's not just a cable. This is carrying huge amounts of current, and 16mm cable typically in most applications is well undersized for 400 amps, but in this instance I'm going to run these pretty hot, so that's why I've got metal glands, and I've got everything physically constrained by bolts. These are bolted into the top here, so they will heat and move and sag a little bit. That's the whole idea of it, but we've got everything physically constrained, and we can run this area in here quite hot. We've got FR4 in there, which will run very hot, so if we're not worried about anything sort of sagging and starting to rub. I've used double wall resin filled heat shrink, the best quality that I could lay hands on, in here, and these also still are single sheathed inside anyway in some areas, or even double sheathed over there, so we've got very little chance of them rubbing on one another and causing any dramas. So after this we are pretty much done on the battery pack. Obviously I have to make a case for it, so I'm going to go with carbon fibre on the outside and aluminium on the ends to allow heat to transfer from the ends of the cells out to outside. I'll be putting some very thin Nomex in there so it doesn't rub and cause a short. Again, Nomex right round, I've bought some of that, so that'll stop any mishaps. Plus we've got 4 layers of capped on there as well, so that shouldn't be too big a headache for us. And yeah, aluminium on the ends. I'll create a heat exchanger so we get rid of heat that way as well, so we can really manage the heat. And we've got our heater packs here if it gets really cold as well, so we can heat our pack up too. And that'll be transferred via the aluminium casings. So you can see over here, these are alloy, and that alloy comes in underneath and goes right through, and that keeps the heat transferring into the center of the case from the outside, and allowing us to manage the temperature of our pack. And we can cool our pack down because we've got our heat pipes here that go all the way down through the core of the pack, and they come up onto this chill plate. And we can reject heat through a radiator, so we can manage both heating and cooling, within reason. Obviously if the ambient's very high, I can't manage that without the use of a heat pump, and I can't fit that on the bike as it sits. So we're going to finish this off, and then I'm going to start to wire all these bits temporarily on the bench all together, and see if we can get the motor to spin up. So probably the first bit, get the controller wired in. Second bit, get the battery charger wired up, ready to roll. Battery management system over here, hidden over the back, and yeah, see if we can get something happening. So I'll catch you later, guys, and hopefully you found this interesting. See ya.